Right. So far what we were discussing is we were using the repository, and within the repository we created a BMM layer with all the columns that is required, and then with the different tables, and we call them as the logical tables. Technically, we were talking yesterday that we create a multi-dimensional model inside our BMM layer, so which is our repository. Okay, so let's try to explore a bit on it, and what is a multi-dimensional model, and why exactly this multi-dimensional is useful, and what are the different features this multi-dimensional model is having, and what do we have in it here. So we'll get to explore a bit on multi-dimensional model, and slowly we'll start discussing about the hierarchies within the multi-dimensional model, and how do we create the hierarchies here. Okay, so if I open the repository that we have developed yesterday, so I can open, and I think it is the repository sales repo 002. Okay, and my password is welcome1. Okay, so this is the repository we developed, and inside this repository we have a couple of tables where some of the tables is having not having a hash, and one of the table is having a hash. As I was discussing yesterday, the table that has a hash is a fact table, and the table that doesn't have the hash is a dimension table. So now, how exactly fact and dimensions are different, and what is the purpose they use it for, and how do we really leverage these features inside the multidimensional model. So we will try to get a grip over to understand all these features. Okay, so first of all, what is a multidimensional model? Right, so this is a very important concept, a multidimensional model, and because that this is the core and fundamental requirement that we have for any data warehouse implementation. So you talk about any data warehouse, you see any data warehouse implementations, and the core concept that we were discussing and implementing, not only discussing, and everywhere you see there is something called a multidimensional model. So what is this, and how do we actually uh, create a multidimensional model, and what is the purpose of creating a multidimensional model? So the name itself says multi-dimensional. So what does it mean by multi-dimensional? Right. So you remember, like, there is a two-dimensional model, three-dimensional model. What is a dimension? Is one perspective. You're looking at one dimension, two dimension, three dimension, which means the the moment you're increasing the dimensions, you're looking at the issue from the more perspectives, right? So suppose a two-dimensional model. So in a two-dimensional model, you have the table. It is a two-dimensional model, so it's a table where my table talks about what? Rows and the columns. Two dimensions. So this is one dimension is the row dimension, other dimension is the column dimension. In the sense, in a database, we have the data in a row and column. So row is one dimension, column is one dimension. In the sense, you're analyzing the data by the intersection of row and column. So this is the intersection of row and column. This is the actual data. So you're looking at the data which is an intersection of row and a column, which is a combination of row and column. Okay, that's a two dimension. So for this particular row and for this particular column, what is the value? Right. So that is basically a two-dimensional, where you have the row column, and the intersection of row and column is the actual data, or combination of row and column is the actual data. So which means you are analyzing with two-dimensional, where one is a row, other is a column. So, but again, in real world, two-dimensional is kind of that is good, but at the same time, that is not sufficient for us to analyze. So probably we may need to analyze the data from a multiple dimensions, so from a multiple perspectives. So what is that we do inside our multidimensional model is, we have a value. Suppose say I would like to analyze something, say sales, right? So assuming that I would like to analyze something called as sales, where my sales can be analyzed from different perspectives. Okay, so suppose then when I say this is my sales, right? So now my sales can be analyzed from the perspective of say product. I'm just giving an example. This is my product, and say my sales can be analyzed from a calendar, and it can be analyzed from a channel, right? So my sales can be analyzed from these three perspectives. One is a product, where I would like to analyze my data with respect to a product, and I would like to analyze my data with respect to a calendar. I would like to analyze my data with respect to a channel. So what does it really mean? Say, assuming that I say my sales is 100,000. My sales is 100,000. So when my sales is 100,000, very good. I mean, I have good sales. So now I would like to understand the same sales 100,000 from the different perspective. What does it mean by different perspective? Suppose say I have 100,000 here. So what does this mean by different perspective? Is basically I want to understand this 100,000 from the perspective of the product. From the perspective of the product. So suppose say now, when I say this from the perspective of the product, what I would like to understand here is what are the different products that has contributed to get this 100,000 sales, right? So now say could be maybe it's a one product, or it could be five products, or it could be 10 products, it could be 100 products. In the sense, I want to look at this 100,000 from the perspective of a product, which means I would like to see what is this 100,000 from the perspective of a product. Okay, so when I'm analyzing my data, when I'm understanding my data, when I'm understanding my sales, suppose I'm analyzing my monthly sales, assuming so my monthly sales is 100,000. When I'm analyzing my monthly sales, what I would like to look at is what is the perspective of my product within my 100,000 sales. Suppose say I may have 20 products available, or I may have 30 products available in my product list. So out of all this 20, 30 product list, and what are the products that has contributed for this 100,000 sales? So that is what I want to analyze. In the sense, so I may have 20 products. Out of 20 products, I want to see in which product has done what, and what product has done more sales, and what product has done less sales, what product has done average sales. So maybe from this I can understand what is the best selling product, and what is the least selling product, and what is the profitable product, what is the fast moving product. So if I look at 100,000 from the perspective of product, I can analyze and understand all these things. So with a combination of these two. Okay, now when I say from the perspective of product, yes, I can understand something. Now I would like to understand the same sales 100,000 from the perspective of a calendar. What does it mean by perspective of a calendar? Right, so my calendar is having what? My calendar is having a month. Say my calendar is having a year, quarter, month, week. We have something like that, right? Okay, we have year, quarter, month, week, right? I'm in general. I mean, I'm giving the list in general. So I have year, quarter, month, week. Now, if I look at my 100,000 from the perspective of a calendar, where this 100,000 could be, say, assuming the for a year. Okay, so no, yes, I mean, I understand I have sales of 100,000 for a year. Okay, but again, this perspective, like in looking at the sales for year is 100,000 is not sufficient, right? Suppose, I would like to understand from the perspective of, okay, within this year, okay, probably not, maybe which quarter has got more money in this 100,000. Suppose, I might have done, say, 50,000 in first quarter itself, and the rest of the three quarters I might have done the rest of the 50,000. So I would like to understand from the perspective of the year, where did I make this 100,000? When did I make this 100,000? So which quarter is good and which month is good, which week is good, so that I can plan and I can understand. Okay, in this year, okay, December is the month where you make most of the business. So that gives me an understanding uh, with respect to my calendar. So the same number, 100,000, it gives a different information, where this same number 100,000, if you look at the product perspective, it will help you to understand the products that are selling good and which is selling good, which is not selling good, which is profitable and all. But if I look at from the calendar perspective, it gives me information within a year, what is the different quarter and different month and week, and which quarter sales is good, and what is the kind of time period which we had done more sales, right? So that is from the perspective of the calendar. So which means same number can be looked at from different perspectives, where as a salesperson who's dealing with the products, you can look at from this perspective. As a salesperson who's trying to look at the information from the perspective of the time, I can look at some other information, same information, but from a different dimension. See, end of the day, whether you look at from here or you look at from here, the sales is 100,000 only. The sales is not going to change. It's the same sales, right? So now, if I look at the same sales from the different perspective, so now say what could be a channel, or it could be, say, my channel could be, say, walk-in or direct. Okay, I can have, say, online or a web. I can say phone. I can say fax. Right? So my channel could be different. I mean, I may have different channels. So there could be people who's walking into the store, or there could be people who's making orders from online. So there are people who's gonna call and give the orders, and there'll be people who will be sending the faxes. So now I would like to understand same 100,000 from the perspective of the channel here. Why? Because, say, I want to understand. Yes, I mean, I did 100,000, very good, but again, 99% of the orders are walk-in, and only 1% of the orders is a web. Now, so there is something that I have understood here. Okay, so when I am planning my things, I know that 99% of the orders are walk-in. Then I have to be careful on the stores and on the setup and all the stuff. Okay, so only 1% is from the web, and that gives me some indication. Okay, so you don't really have much web orders. So probably that will help you understand. Okay, okay, now we are not at all doing good through web. We would like to improve our web marketing, or we would like to see if we are lagging something inside our environment, where we are not able to push the web environment better, or people not actually using it, or even if they're trying to use it, but the site is not good, and it could be anything, so I would like to understand from a different channel's perspective, where how and uh, what I have achieved so far. So now the same 100,000 sales is actually analyzed from the different perspectives. The same information, but you're looking at what you need from your perspective. So same 100,000 could be, see, imagine 100,000. My total sales for a year is 100,000, where the 80% of the sales may be done by one product, assuming from the product perspective. Now I want to be very very sure that I make sure this product is available in stock, or this product is available with us, or this product is well promoted in the market. Otherwise what happens, if that sales has gone down, then my 100,000 is gone. And so I need to make sure, like, what exactly from the product perspective. So what is the different um, precautions, what is the different steps that I need to take, I need to uh, I need to improve or implement to increase my sales from the perspective of the product. If I look at the product, so now I know that 60% of the sales is done on the Christmas season. So I need to be very very sure that I have the staff available for the Christmas season to work, and I have the stock available, and I have this and that available. Because if I miss this Christmas this time, then I will not be able to receive reach this 100,000, because 60 to 70% of the sales is done out of 100,000 is in a Christmas season. So I would like to. So Christmas season is very important for me, and from the channel perspective, and suppose a 60% of the sales is from the web, then I need to make sure that yes, my web has to be up and running, and I have to validate each and everything, and I have to make sure that my web is ready and available 24 by 7 without any disruptions. Okay, so that I have it. So otherwise, suppose say, what is that I can understand here? If my web is down for a week or 10 days, then obviously 60% of my sales is gone. I mean, I'm just giving a hint. So this gives us an understanding what is that we actually need to do from the different perspectives. Even that's what we do, right? I mean, in our real life, that's what we do. And suppose say if I have, like, take an example, this discussing in our life, they say, assuming this as an expense. So if I am assuming my fact, or my number that I'm analyzing is an expenses. Suppose say if I have expenses 100,000. Suppose if I have expenses say 100,000 a year. If my expenses are 100,000 a year, I would like to understand my expenses from the different perspectives. Right. So what are the different perspectives that I would like to analyze? Suppose say if I am actually doing similar exercise for real life business scenario. So this is my expenses, where I would like to analyze my expenses from different perspectives. So what is the different perspectives here? Say, this is one perspective, this could be another perspective, this could be another perspective, this could be another, this could be another. Right, so this is my expense, where I may be analyzing my expense with respect to my say stay or rent or whatever I can say. Okay. Okay, and food, travel. I can say stay, food, travel, uh, books, shopping. Now, when I want to analyze my expenses, I would like to analyze my expenses from the different perspective, and the rent and stay is one perspective, and food is another perspective, and the travel is another perspective, and books is another perspective, and shopping is another perspective. Right? So now, say this say 10,000 a month, assuming. Okay, so now I would like to analyze this 10,000 with the perspective of the stay. So how much I'm spending for stay in this 10,000. That's one perspective. Okay, so from the food, how much I'm spending. What is my expense from the perspective of the food? What is my expenses from the perspective of the travel? What is the book expenses from the perspective of books? What is the expenses from the perspective of shopping? So they are different, right? Suppose if I have 10,000 kind of which are my expenses, then I can look at from the different perspective what is exactly the combination. So uh, from the perspective of a stay, how much I'm spending. So out of 10,000, so probably now I may be spending 2,000 for a stay. And so this is the perspective. So now from the expenses, from the perspective of the stay, what is my expenses got to do? So now I can understand like what is that I'm spending here, and what is my expenses with respect to my food, what is my expenses with respect to my travel. So now looking at one number, one expense from a different dimensions, different perspectives, because it is very important for me to understand. Knowing 10,000 or my expenses is good, but again out of 10,000 what exactly you're spending is also very important. For this 10,000 what exactly you're spending is also very important. That's what we call it as analyzing the information from the different perspectives. And this is what we do in our real life without even having a multidimensional model. So, but again, see, multidimensional model is built from our real life scenarios, real life example, the analysis that we do on real life. Okay, where within a multidimensional model, we call a table which we are actually analyzing the information, which I call it as the table, which is a fact table. The table that we analyze, the table that we have measures, the table that we have numbers which we would like to analyze is, I call it as a fact table, where we'll fill up all the numbers here which I would like to analyze. So that table we call it as a fact table. So fact table is the table with the numbers, and the rest of the tables where we analyze our data from the perspective. So the perspective we call it as a dimension. Say I can say dimension 1, and I can say this is a dimension 2, and I can say this is my dimension 3, which is, if you look at it, is a combination of fact and dimension. So there is a fact table, which is a table that is holding your measures or numbers which you would like to analyze. Now you are analyzing the same fact from different perspectives, which is nothing but from the different dimensions. So there's a dimension 1, there's a dimension 2, there's a dimension 3. So now same information is looked at from the different dimensions. We call that as multi-dimensional model. So multi-dimensional model. So in a multi-dimensional model, we are talking about a combination of fact and dimension. Remember, multi-dimensional model is used for reporting only. It's the purpose of the multi-dimensional model is what? Reporting only. Because in a multi-dimensional model, we have a dedicated table which we call it as a fact table, where you move all your information or your numbers into one single table. See, the organization of tables. So, at the end of the day, whether it is a normal database model, which is a two-dimensional model, which is a combination of normal tables. So you have entity relationship model, right? You have the tables and you have the joins between the tables, and you have the normalization process and all the stuff. Where in a data modeling, you have that stuff where you create multiple tables and you join them. You pull the data from these tables with the different combination. That's basically your data models. So in a data modeling, we have like a normal data model, like which is like an ER modeling, entity relationship model, which we use for our OLTP applications, and the other is multi-dimensional model, which we define it for the reporting application. So in general, the entity relationship model is mostly used for the operational systems where, suppose if I would like to build a store system where, I may have to build a system where, it has a multiple tables and that the tables is having relationships. So the main purpose of my entity relationship and the model that I'm the normalized model that I'm creating for my operational system is what? To capture my day-to-day transactions and to perform my day-to-day transactions. That is one thing. So where my entity relationship model, which is nothing but a two-dimensional model, will have a lot of tables, loads of tables. So which, in other words, we can also call it as a normalized model. So if you look at normalization, so what is a normalization? Um, Normalization is basically um, arranging your information in a way that you don't have any redundancy, or you don't have any duplicate data, or you don't have any information that is captured uh, in more than one place within your system. Why? Because that will cause inconsistencies, that will cause a lot of problems. So in a normal day-to-day applications or OLTP applications, we always implement normalized model, which is nothing but a model that is more suitable for day-to-day operations where where you have one table is split into multiple smaller tables, just to make sure that we don't store any redundant data, and we relate them and we join them and we pull the data from those tables. That is my interrelationship, which is a normalized model. But whereas when I look at from the perspective of the reporting, right? So the problem with the reporting is entirely different. Day-to-day transactions are different. In a day-to-day transactions, we are trying to get the details of the transactions, but in the reporting, we are talking about getting the transactions like in a few hundreds and thousands. Suppose say in a day-to-day transactions, I may want to understand with the transaction level. So probably I may retrieve one or two records. Suppose if you want to understand from a table, what is the purchase done by a particular customer. So I'm talking about one single customer where I can simply go and pull the data from the tables, because in a day-to-day transactions, if a customer comes, I'm dealing with one customer. It's not like I'm dealing with thousands of customers. We don't do that. So suppose when I go to a store and I give a product where he will scan the product, right? So the product scan is a single scan, right? It's not doing like hundreds of scans. But again, yeah, they may be doing, but again, at a time we are not doing all the stuff. So it's always a single transaction. So now, even though you have the data split across multiple smaller tables, so joining and getting the data for one single record is not a big deal. So you will get the data very quickly. But imagine, when you're doing the reporting, suppose say I would like to understand the annual sales. My annual sales could be 1 million records. Now, when I am actually want to look at the report on 1 million records, so obviously getting the data from multiple tables is very difficult. That is the reason we organize the data differently for the reporting. That's what I call it as a multidimensional model. So multidimensional model is only optimized model created for the purpose of the reporting. So though you have the data captured in the tables only, but we capture a little different in our multidimensional model with a combination of two types of tables. One is the tables with numbers, tables with non-numbers. So the tables with numbers, I call it as a fact table. The table with non-numbers, I call it as a dimension table. Why is this? Why do I really see in a normal database model? I'm not actually segregating it as tables with number, tables with not numbers. All of them are tables, and all of them will have the numbers and the non-numbers. But why am I actually talking about tables with numbers and non-numbers here? Is basically the volume of the data that we are actually analyzing is more in reporting, right? So that is the reason we would like to understand, or we would like to segregate the information as numbers and non-numbers. Because suppose say, I'll give you a simple example. If I say annual sales, assuming the sales, annual sales from the perspective of the product. So now I may have a product. There is one, the report. See, the report requirement is a product category category ID, name, sales. So now if this is my report, generally the reports looks like this right now. So there is some number that I would like to analyze, where now I would like to understand from the perspective of the category name. Now if you see here, category ID, category name, so could be in my entire product, I mean in my entire store products, I may have like say 10 categories or 20 categories max, which means my category information is only 20 rows, where I have 20 different type of categories. But if I look at my sales across my year, could be a billion records or a million records. Now where my category information is just a matter of 20 rows in a way, where my sales information that I need to analyze is from what, a million rows, which means if I have to get the numbers for this particular thing, where these two columns that I'm talking about, 20 rows, and this sales information is, I'm talking about a million rows. Now, so if I actually split as a two parts, so I'll take 95% of the time to pull this information for the million record sales and aggregate it and process it and gather it, where it will only take me 5% of the time just go and get the data for the product details. What is the different categories available, and what is the value from the perspective of that particular category. So which means when I run a report, 90% of the time we spend on calculations. 90% of the time we spend on defining the calculations or calculating the data. So that is the reason I always keep my table with the numbers as a fact table with only numbers, and I will try to keep it as simple as possible, as efficient as possible, because when I make 95% of the effort, my table has to be very simple and lean, so that we know when I run a query, and this will work effectively. So, but again, see, in a multi-dimensional model, there is one more concept that we have is a denormalized. As I said, the entity relationship is normalized, and my multi-dimensional model is denormalized. When I say denormalized, we merge the data, and we can have we combine the data. So I may have the data from multiple systems. When I'm talking about my data warehouse, what is that I'm going to do? I'm going to stack up all my systems in one data in one system, which I call it as a data warehouse, which means data warehouse is a collection of data from different sources. So I store all my warehouse all my data. So when I'm talking about like a huge data kind of being loaded into the tables and filled up in the tables, and again getting the data from those tables and analyzing is a very complex task, because the table sizes are huge and information is very high. So that is the reason. So rather than having the same model that is being used in normalized model with the smaller tables, what they did is, when you talk about a reporting model, which is a multi-dimensional model, they actually split the tables as a two types of tables, numbers and the non-numbers. So they move all the table data with the numbers into one table, in the sense all the calculation that I would like to do, and try to make it as simple as possible, because this will take 90%, 95% of the time for any report that you run. So I would like to make this table a table with a lot of efficiency, and this table where I may have like uh, information, but again this is only I'm using to understand from the perspective, in the sense just to describe this information. So I may take 90% of 95% of the time to calculate my sales, but only 5% of the time to describe my sales. If I look at from the perspective of the execution time, when I run the report internally, the report may take 95% of the time to calculate the annual sales for the different product categories. But just to describe the name of the product category, it may only take 5 minutes, because my product table is having only 20 categories. But these 20 categories across the year has generated few millions of records. And to calculate those aggregated value for each product category, I may take 95% of my query execution time or processing time. And once it is done, only 5% of the time I may use to describe what is the name of the category for each category ID. So that is the reason, keep all the numbers in one table that you would like to analyze and make it as simple as possible. So the table has to be very, very light so that when you run the queries, it will perform better. So by nature, the reporting is entirely different than day-to-day transactions. Since the reporting is different and the data for the reporting also has to be stored in a different way, which is optimized for the purpose of reporting. So that's where the multidimensional model came into the picture, where we organize the data with a combination of fact and dimensions to understand my information effectively. So that's what multidimensional model concept of a fact and dimension. That is the reason when I'm creating a model, I'm actually talking about defining my data as a fact and dimensions, where in a fact table I would like to keep all my numbers that I would like to analyze. In a dimension table I would like to keep all my descriptions that I have. Okay, so now if I look at here, I'll give an example. Say let's take that you have something. Okay, suppose you may be thinking, suppose say if I say that this is the table with numbers and this is the table with non-numbers. So if I look at here, so there could be some numbers here. Suppose say in my time, right? So I may have year. Suppose say if I look at the year, what is the values that I'm looking at? If I look at the year, the values is 2009, 2010, 2006, 2007. So these are numbers only, right? They are not text. So why my year has to be? Why am I keeping my year here? Why can't my year go here? See, number is different, and the number that you are using for the analysis is different. Even phone number is a number, right? If I'm talking about numbers and non-numbers, if I'm really segregating my data from the perspective of numbers and non-numbers, but again, numbers that I actually require for the reporting is something that I need to add in the fact table. Not all the numbers, like phone number and pin code. Those are the numbers, but those numbers you don't really use them for the analysis. Do I analyze my phone number? I don't. Or do I analyze the postcode? No. We don't add up postcodes, right? We never add 100 postcodes and see what is the result for all out of all the 100 postcodes. No. So that they are not the ones that is uh, something that we actually analyze. We always talk about number from the perspective of what is my sales, revenue, profit, margin, those things that I want to see. So out of all my data, what are the numbers that I actually use for the business analysis? And I keep all those columns in one table. I call the table as a fact table, and all the descriptive items, rest of the kind of all the nonsense, I can say. Rest of all the information that uh, you need, you can put it in a dimension table, something similar to it, and where I can analyze this information. So though my dimension tables are usually very, very huge, very, very big, but I want to keep my fact table as lean and thin as possible, because 95% of my query time is depending on the performance of this fact table. If the fact table is small and it has a kind of less number of columns and everything, then the query will run faster. So in a reporting, since we are dealing with a few thousands of millions of records, if my fact table is efficient, if my fact table is kind of lean, then my query performance will be better. If my query performance will be better, then my reporting time will be much faster. So there's two things that we are looking at here. In a multidimensional model, we arrange the data differently, where we call that arrangement as a combination of fact and dimensions, where in a fact table we add all the numbers that is required. In a dimension table we add all the descriptive items, like product, customers, and all the stuff. So this is what the purpose of my multi-dimensional model. So now I cannot avoid creating a multi-dimensional model here in my BMM layer, because without a multidimensional model, my OBIE will not be able to do any reporting that is required. In the sense, you can still do, but again, it is a core and a whole idea building up this kind of solution with the combination of multidimensional model, because even the reporting part is leveraged based on this model, because we can create a lot of things like hierarchies and drill downs and this and that, where you can only do all those things in the reporting provided you have a multidimensional model here. So that's what I'm talking about, a multidimensional model, which is a combination of fact and dimension. So this is a fact table where I have my revenue, where I'm having a kind of something on the revenue and the unit, where I have a dimension table which I have the product, where I have my product descriptions and all the stuff. So now basically this is a descriptive item. So now if I want to analyze my revenue for last 1 year from the perspective of product brand, so now I may have 10 brands, but again these 10 brands have made 1 million records over a year. So first of all, what is that I do? I do the calculations for a year revenue, which is a few millions of records. Once my calculations are done from the perspective of brand ID, right? Then I get the brand ID and the revenue, and I go to my product table and I get the brand name for a particular brand ID. Simple. How many brands I have? 10 brands. So how long it will take? A split second, because I need to go and get the data from my brand table, which is having 10 brands. So 1 million records is processed, will take like say 5 minutes, and 10 records process may be taking 5 seconds, 1 second. So imagine like another difference. So I always try to keep this revenue table as light as possible, as simple as possible, where we stack up this table like dimension tables. Dimension tables are usually huge, like 200 columns, 300 columns, with loads of data. But again, since I'm not actually processing all the data, I'm only getting the required data from the perspective of my result, right? So probably we'll always picking up some data from my dimension. We're not actually full-fledged processing the all the rows in the dimension. That doesn't happen. So it's always a select, where we select only few rows. So I mean the queries are very light from the perspective of the dimension, because we'll only pull the data that is needed for us. Okay, so that is the arrangement of information in my database for the purpose of the reporting. In simple I can say that's the arrangement of information in my data warehouse for the faster and better retrieval of the data. And we also call that arrangement as a multidimensional model, where we store the information in a combination of numbers and the non-numbers, where the numbers are called fact tables and the non-number tables are called dimension tables. When I say non-number tables, don't think that I have some number here, where can I use it in my dimension table, or I have to move that column in my to my fact table. See, I mean, when I say non-number dimensions or non-numbers, it doesn't mean that I cannot hold any number. Yes, you can still have the numbers, whatever that you want. But see, the idea is, are you using that number to analyze or not? Are you actually analyzing any of your business information, or is that number is something that you would like to use for the analysis purpose? Okay, for an example, phone number is a number, but again I know that though it is a number, but that there is no purpose of analyzing your phone number, because that's not something that you want to analyze. So those kind of things, even though you have a number and you are not planning any analysis on that number, then you don't really need to keep it in a fact table. But suppose a revenue, I want to analyze my revenue. I may want to talk about the stock, or I may want to talk about a profit. I may want to talk about a margin. I may want to talk about quantities. So those are all the things that we analyze. So those numbers will keep it in a table. We call it as a fact table, and the rest of the columns, though they are the numbers, they can be part of dimensions, because I have no plans to actually use those columns for the processing purpose or analysis purpose, where they are only descriptive columns. So don't confuse yourself saying okay, fact table is only with the numbers, but again my dimension is also having some numbers. Now what do I really need to do with those dimensions? Can I call that as a dimension, or is it a fact? It's not that numbers are non-numbers, but again, the numbers that I use for purpose of my reporting are for my analysis, and the rest of the information is kept as a dimension, so that we don't really load up this fact with too many columns. Okay, and so this is what your multi-dimensional model is, which is a combination of fact and dimension. The purpose is effective and the better reporting. Now, what exactly my multidimensional model will give you? What exactly my multidimensional model will help you? So, see, in a OLAP scenario, so what is OLAP then? Now, there is another concept that we are talking about is an OLAP. So, what is this OLAP is all about? Why do we really need a OLAP? See, again, OLAP is another concept, online analytical process, I believe. Right. So, this is again a standard that will help you to define what is the effective way of doing the reporting. What is the effective way of doing the reporting? So now there are people with intelligence and people with a lot of knowledge in implementations of reporting for the different business requirements. What they have done is they sit together and they come up with standard guidelines and the standard requirements saying, okay, if you're building a reporting and these is the things that you should have, these are the things that you really need, because that will help you to build a better reporting. So if there is a kind of a situation where you actually talk about, uh, this standard tools and procedures and everything that you must follow or you better follow for the good reporting, from the reporting perspective, we call it as an OLAP. So online analytical process, which is basically a set of standards that are a guidelines that will help any vendor who's building the reporting application, any vendor who's building the reporting application to follow, right? Suppose I'll give an example, some kind of a traffic signal. So whoever is building the traffic signal things, or whoever is building kind of selling the traffic signal stuff, so they have to follow a standard where they'll keep the colors like red, green, amber, right? So if somebody is trying to sell traffic signal with different colors, would they be able to sell? No, nobody will buy, because that's not actually the standard. Okay, the same way here, when I'm talking about analysis, so my OLAP is also a standard where all my reporting applications, whether it could be in OBIEE or Cognos or any other reporting tool, so they are actually built on the OLAP principles. So now if you look at all these reporting applications, they follow a certain standard, say OLAP standard. So that way we are building the applications based on a standard, just to make sure that we are following the market standard. In the sense, suppose if I am talking about OBIEE is a multi-dimension, or OBIEE is an OLAP application, or OBIEE is an OLAP compliant reporting tool. What does it mean? It has a compliance with the kind of definitions of the OLAP. It's compliance with um, the rules and regulations that is defined, and the guidelines defined inside my OLAP. So that when suppose say OLAP says you should support a multi-dimensional structures, OLAP says it should provide drill downs, OLAP says you should provide hierarchies, OLAP says you should provide this, OLAP says you should provide that. So all those things has to be provided, or all those things that is defined in the OLAP has to be supported in any tool that you're developing. Suppose say I have a standard phone. Phone has a standard. So if you are manufacturing a phone as a market standard, phone has certain things. Say a smartphone, assume. So now, what is the different things that you expect out of a smartphone? You should be able to call, or you should be able to send the messages. You should be able to receive the messages. Maybe this is the basic features, but again, in a smartphone, so probably you may want to have a touch screen, or you may want to have say browser, or you may want to have you should be able to access the internet, you should be able to do this, do that. So there are certain things when you say smartphone, there are certain things that you should have. So now when I say I'm a vendor, I'm manufacturing a phone without calling facility. Do I call that as a phone? No, because a standard says if you are manufacturing a phone, you should be able to call, or you should be able to receive the calls, or you should be able to send the SMS. These are the standards. These are the kind of the basic market standards. I cannot imagine somebody manufacturing a phone without the facility of SMS. Make no sense, right? So that's what my standard. So when my phone manufacturers, whether it is Samsung or iPhone, they'll understand these standards, and based on that they'll kind of manufacture their product. The same way here, OLAP is also a standard. When people like Oracle and IBM or Microsoft, when they are creating the reporting tools, when they're building and manufacturing the reporting tools, they'll also keep that in mind, where they are following the standards of the OLAP, so that people can accept it, people can use it, because the standard is something that we always follow. Okay, so now my OBIEE tool is a OLAP specific tool. So since my OLAP tool, one of the requirement of my OLAP, which is online analytical process standard, is what my data should be in a multi-dimensional model. That is the my data should be in a multi-dimensional model for any OLAP compliant tool. That is the theory talks about. That is the compliance talks about. Now, if that is the case, I am building a multi-dimensional model inside my repository, because my OBIEE, which is an OLAP tool, should have this. Then only I'll be able to create my reporting. So that is the reason we are building a multi-dimensional model where my OBIEE can use this data better way for the purpose of analysis. So that's one of the fundamental requirement. That is the reason, irrespective of what you have to create a multi-dimensional model inside your BMM layer, because your OBIEE needs a multi-dimensional model for creating the report. Now within the multi-dimensional model, it's not that you only define a multi-dimensional model like in a fact and dimensions. We'll also create additional things, additional features like in hierarchies, drill downs, and all the stuff on the dimensions, where we'll explore those hierarchies tomorrow. So we'll see how do we create the hierarchies on this multi-dimensional model, what is the hierarchies all about, and how do we organize my data, how do I further drill down my information and analyze my information from the perspective of your multi-dimensional model, which I will explain you tomorrow. So but ideally the idea is just to understand what is a multi-dimensional model. So there are a lot of books that is available on the data warehouse concept. These are a part of data warehouse concepts. When there is a books you can download from internet, you search it. Otherwise, let me know. I can upload. So there's a lot of data warehouse concepts. So remember, data warehouse concepts is very very important from the perspective of interview. Right. So when you go to the interview, you should be able to not only by heart, what is a fact table, what is a dimension table. No, don't ever try, but understand. So now that I explain, can I spend time? So why do I really need to have tables which is like in a fact and dimension? What is the purpose? Why don't I call it as a table? Why am I calling it as a fact table and dimension table? So these are the things that you should answer yourself. You should convince yourself, saying, okay, this is required. Right? Suppose say that is very very important. Before you learn anything, before you use anything, you have to accept the things, right? I mean, so to accept the things, you have to convince yourself. So now suppose say if I'm talking about a person, so um, I say he's a good person, suppose, assuming. So now, first of all, if I have to kind of make friendship with him, I have to kind of spend time with him, I need to first prepare. No, he's a good person. So now to come to a conclusion he's a good person, I need to kind of know certain things, right? The same way here, when I say that, okay, for a multidimensional model, factor and dimension is required. So to conclude, like in multidimensional model, you need a factor and dimension, but you need to understand why do I need a factor and dimension. So you have to convince yourself, okay, yes, I mean, yes, for this you need a factor and dimension because you're doing this. So you have to convince yourself. Once you convince yourself, then only you can accept the fact. So now I say that, you need a factor and dimension for a multi-dimensional model, and you only know that you have to use a factor and dimension, but you are not convinced yourself because you don't have a clarity. Why do you really need a factor and dimension? But if you know the information, then you're convinced. When you convince, you can answer the questions easily because you understand what it is. So that's how you have to build up some you have to build some theory around what we are discussing. Apart from what we are discussing, you also have to go through some kind of theory, knowledge base and books, understand the data warehouse modeling, what is a fact, what is a dimension. There's a loads of information in the data warehouse where what are the different type of facts, different type of dimension, this and that. You don't need to go too much depth, but yes, I mean to a kind of an understandable level. Just go through that information so that it will improve your knowledge in data warehouse concepts. So when you go to the interviews tomorrow, you can talk better because see the problem is I mean from my experience. So when you go to the interviews, most of the times people who interview you at the technical level may not be very technical, especially like the countries like US and UK. You go to the interviews, like people doesn't really ask you questions like can you tell me, can you explain me the steps creating the hierarchy. Okay, step one, step two, step three. Nobody will ask those kind of questions, and nobody will ask you like uh, uh, few technical answers. Right. So from the perspective of the interview, like you have to have uh, kind of a reasonable understanding on concepts where you should be able to talk because the other person may not be really technical. So especially when you go to the manager round or the you can say face-to-face round or the second round after the technical, nobody will really talk to you on the technical because the manager, the BI manager or some manager who's talking to you may not even know the OBI tool. He's only a manager who manages the BI team, but he doesn't even know anything from the perspective of technology. But he knows, yeah, he knows what needs to be done. I mean, the concept of the data warehouse, like what you're implementing, what is your numbers, what is the facts, what is the dimensions, and what you're analyzing. They are the common for every tool, right? Now, when you're talking to him, he cannot ask questions to you on the OBIEE. He cannot ask like, what is this BMM layer? He doesn't really know. So you need to have a theoretical understanding of the data warehouse concept because most of the people in the interview when you're talking, they may talk from this perspective because they only know that. They don't know OBIEE, right? So, and again, yeah, that's very important because uh, otherwise what happens, you only talk about OBIEE, you know OBIEE very well, you don't know these general topics. Then he's talking something and you're expecting him to ask certain questions and he's not asking, and he's expecting you to answer certain questions and you're not doing. So that's where you'll fail. So kind of building the concepts is very very important because technical, like we can learn it, and technical all comes in when you actually go and perform your job. But again, before that, to get into the job, having a theoretical knowledge is very important. That is the reason we spend a lot of time to understand the things, so that we can go and talk. So otherwise, it's very very difficult. Okay, yes, I'll copy those books. I think I should have somewhere. Yeah, I will copy those things into the OBI folder somewhere. I mean, in the documentation folder that I've shared you, right? In that I'll copy. Just okay, I have a very big question. Multi-dimension. I have a question from Nagan. The multi-dimension table is something that is at the BMM layer, right? The underlying physical tables does not conform to the OLAP standard. If yes, then would be OBIEE prevent. No, 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 no. See, the beauty of the OBIEE is, since I have the data in my physical layer, which is in a normalized model. It's not in a multidimensional model. So to help the OBIEE to create reports, we are building multidimensional model. Since we don't have the data in a multidimensional model in my physical sources, I am building up something logical, which is in a form of the multidimensional model. So where for OBIEE, yes, my data is in a multidimensional form because my OBIEE will use these logical structures as a fact and dimensions for the analysis. But end of the day, the data may be in a two-dimensional form, which we'll be retrieving. But again, for the OLAP purpose, yes, the logical structures are built with the data that is required, which my OBIEE kind of reporting is looking for. So since we don't have the data in multidimensional format, that's what we're trying to do. We're trying to build the multidimensional format and which will give the data to the reporting. So that's the whole idea. Okay, OBIEE supports multiple sources. It's not that it has to be a multidimensional source, but again, internally what OBIEE does is it will convert the data from a normal source to a multidimensional source. That's what we do in a BMM layer, where we give this multidimensional structure to OBIEE. Though it's a logical structure, we'll give it when it asks the question, we'll get the data from the two-dimensional data, which is the tables, and fill the structures of the multidimensional with the data, so that my OBIEE can use this multidimensional data filled within the fact and dimension tables and do the report on that data. So it's kind of, we are building a layer in between in a multidimensional form based on my two-dimensional form. But if you already have the data in the data warehouse in a multidimensional form, my physical structure itself is a multidimensional, which is much efficient. So you don't really need to struggle of getting the data from multiple normalized tables, and so your query performance will be better. So that's the difference. Okay, so anybody has any other queries? Anything that you don't understand?
Hey Dinesh, this is Senthil here, Dinesh. One quick question, like actually yesterday when you were saying about the physical layer and the BMM layer where you create a diagram on the physical layer and also you did the same exercise on BMM too, right?
Mm-hmm.
So is it required to do it in both the places? Why can't we do it only in BMM rather than not doing in physical? Because
See, no, okay, I'll give you, yeah, that makes sense. Your question makes sense. See, now, I mean, I did it in both the layers, more or less same. Maybe because the model that we have taken is very simple and straightforward, where I have only few tables. Imagine, I may have tables like 100 tables in my physical layer, where, for an example, say product, right? I may have one product table here, which I simply connected to my revenue. Suppose, say, assuming I may have a product tables, like I have 10 product tables. When I say 10 product tables, not all the product one, product two, product three. It's not that like that. No, I may have a product table. I may have a table for product category. I may have a table for product information. I may have a table for product descriptions. So which means in a normal operational system, my tables are in a normalized, right, where I split the table into multiple smaller tables where I join them. So in general, when you talk about the physical layer, you have loads of tables which you join together. And out of 10 product tables, what is that I'm doing? I'm creating one logical table which is called products here. So my logical table products is different, and my these 10 product tables are different. So in the physical layer, we'll have more joins or more relationship between the tables, where in a logical layer, I'm building something logical, where I am not actually talking about how these two tables are joined from the perspective of a physical join. It's a logical join. When I say logical join, I don't really care like primary foreign key here. So now what column in this table is this, what column? It's not a primary foreign key. It's a logical. What table is from what perspective? So what is a fact table? What is a dimension table? And what table I'm analyzing with respect to what table. So this is a logical join. So these joins in BMM layer is different, which is a logical joins. The joins in physical layer are different, which is a physical joins. So from the perspective of our scenario, we are using more or less the same tables in a physical layer and the BMM layer, but we may sound, why am I doing this exercise in two places? Why can't I simply do it in one place? But if you look at from the real perspective, the tables that I use, the combination of joins that I create, and the combination of things that I do in a physical layer is much exhaustive, because I end up having too many tables in my sources which I'll pull the data from. Whereas, I consolidate. So multidimensional model, the purpose of the multidimensional model is what? I merge the tables, which is a multiple tables, into one single table. I call it as a dimension table, or in other words, we call it as a logical table, where after building the logical tables, I need to provide a logical relationship, not the physical. So this will have a physical relationship which talks about a primary foreign key and the condition to pull the data from the database. But this doesn't talk about primary foreign key, because anyway, end of the day, the logical query which says that data from this combination to this combination needs to be retrieved. That's what my logical says. But the same will be converted as a physical query. How do we get this data from this combination to this combination based on these tables and the queries that we talk about? So we have to create two um, kind of relationship with the two places, where this is a logical relationship that explains how the tables are related from the business perspective, how the tables are related from the technical perspective here. Okay, but again, see, when you define the relationship, when you drag and drop, it will automatically use it. But again, usually you don't. Suppose if I have 10 tables, if I define the join between 10 tables, can I drag all the 10 tables to here? I don't, right? I'll create only one table products, and I drag the few columns from this table, few columns from that table. I'm trying to build up something new here. So dragging and dropping, you don't actually do as it is. So we'll build the logical tables, and we'll build the logical relationships. So creating the joins in one table and using it here is possible in few scenarios, but in a traditional approach, or in a general data warehouse implementations scenarios, you cannot really drag and drop, because if you do that, and it means that your scenario is very small, and your scenario is not having multiple tables in your physical layer. That those cases like this, it will work. But again, in general, if you have a huge number of tables, where you have built your logical tables with a combination of multiple physical tables, you have to define your own logical joins here, because your logical table is entirely different, which doesn't exist directly in your physical. Make sense?
Yes, Dinesh, thanks.
See, OLAP is not an OBIEE standard. OLAP is a market standard. It's kind of a generic standard that is built by few people. It's a kind of it's some standard body, okay, where they take care of defining OLAP features and OLAP principles. So it's like, as I said, a traffic light. You have ISO standard, you have CMM level standard, so you have standards defined, right? So, and when you're building a product, when you are applying for the CMMI, and what do you do first? You go through the CMMI standards and see that if your office is compliant with the CMM standard. If not, you build compliance. It's the same way here. When I'm building a product, I understand what is my OLAP standard says. Okay, OLAP standard says you have to have hierarchies. OLAP standard says you have to have the factor dimensions. OLAP standard says you have to have the drill down features. So the vendor, which is an Oracle or any other vendor who's building a tool like OBIEE, make sure that the tool covers all the OLAP specific features. Say I may have more features also, doesn't matter, but at least I should be compliant to understand. I should be compliant to implement the basic features that is specified in the OLAP standard. That's what. Okay, right, guys. Then we'll see tomorrow. We'll start creating the hierarchies. We'll try to analyze my data from the perspective of the hierarchies, and we'll understand. Okay, right, guys. Good night.